So now we're going to talk about multiplying rational expressions. So before we do, we're going to talk about what does it mean to multiply a fraction. The reason being is because the rational expressions that we're going to be looking at are going to be in the form of fraction times a fraction, but instead of having a single number or a single quantity on top or on bottom, we're going to have polynomials on top and bottom. So you learned before that you can multiply straight across with fractions, that you do not need a common denominator. You also at some point learned that if you want, you can cancel or reduce first with fractions when you're multiplying. So I'm going to go ahead and say 3 and 21 have a common factor of 3, and I'm going to take that out and get 1 and 7. 5 and 10 have a common factor of 5, so I'm going to take that out and get 1 and 2. Multiplying straight across the top, I get 2 over 7. So notice what I did. I reduced by canceling common factors, and then I multiplied straight across. I am going to do that same thing with rational expressions. However, when I have polynomials, I cannot reduce when I have adding or subtracting, so I first need multiplication. So the very first thing I'm going to do is factor. Once I've factored, I will reduce by canceling common factors. I will then multiply straight across, and I will also be sure and list the domain. And once again, I must list the domain in the non-reduced form, or from the non-reduced denominator. So let's look at two examples to see what I mean. So looking at the first example, the first thing I'm going to do is factor this. So I see that on my first fraction here, x minus 5 has no common factors, and it's just a binomial, and it's not perfect square minus perfect square, so that's not factorable, so I'm going to go ahead and rewrite it. 3x squared plus 5x minus 2. I'm going to go ahead and guess and check. So I'm going to use some room up here to do my guessing and checking. So I'm going to go ahead and guess that in order for my first times my first to multiply to be 3x squared, I'm going to need a 3x and an x. And I'm going to guess that in order for my last times my last to multiply to be negative 2, I'm going to need a negative 2 and a positive 1. So now when I check, 3x times x is 3x squared. 3x times 1 is 3x. Minus 2 times x is minus 2x. And minus 2. So I have the correct first, I have the correct last. However, notice my middle does not add up to 5x. So I'm going to go ahead and guess again. Well, I'm going to guess, what if instead, so I'm still going to know that I'm going to have a 3x and an x. So what if instead I say, what if I have 3x minus 1 and x plus 2? Because I also still know that I'm going to have minus 1 and positive 2, because I'm still seeing what's going to multiply to give me my first and what are my last that are going to multiply to give me that last. So now I check again. 3x times x is 3x squared. 3x times 2 is plus 6x minus x minus 2. And now my middle terms do in fact combine to be positive 5x. So that looked like a good guess. So my top is 3x minus 1 and x plus 2 times, doing the same thing over here. I see x squared minus 25 is in the form a squared minus b squared. I know a squared minus b squared factors to be a plus b times a minus b. So x squared minus 25, my a is x and my b is 5, giving me x plus 5 and x minus 5. And I'm going to go ahead and guess and check again on the bottom. I know, again, in order to get 3x squared, I'm going to need a 3x and an x in the front of each. I'm going to go ahead and guess, because I know I'm going to have a minus and a minus for them to multiply to be 2. I'm also hoping that I get one of these common factors. So I'm going to go ahead and guess 1 for minus 1, because then it would cancel with this 3x minus 1. And because I need something then to multiply by negative 1 to give me 2, I'm going to guess minus 2. Checking, I get 3x squared minus 6x minus x plus 2. Notice my middles do add to be negative 7x, so that's a good guess. So I'm going to go ahead and use it. Okay, so now I've done step 1, I've factored. Step 1 is usually the hardest part on these, because reducing is going to be easy for me. All I'm going to do, because now it's all multiplication, is look for common factors. Well, I can cancel an x minus 5 and an x minus 5, a 3x minus 1 and a 3x minus 1. And then when I do, I'm left with x, no, now I'm multiplying straight across, I'm left with x plus 2 times x plus 5 on top, and 1 times x minus 2 on the bottom. I have to list my domain. So in order to list my domain, I'm going to look at my non-reduced denominator. So I'm looking at all three of these pieces. If any three of those pieces equal 0, then my denominator will equal 0. So I'm going to say, when does x minus 5 equal 0? When does 3x minus 1 equal 0? When does x plus 2 equal 0? Well, x minus 5 equals 0 if x is 5. 3x minus 1 equals 0. Well, if I add 1 and divide by 3, it equals 0 when x is 1/3. And x plus 2 equals 0 when x is negative 2. So the domain for this function is x cannot equal 5, x cannot equal 1/3, and x cannot equal negative 2. So here's my final answer along with my domain restrictions. Looking at the next example, and the last example too. Going through my steps, which I know aren't in front of me right now, but hopefully they're in front of you since you either wrote them down or printed out the notes template. So first thing I'm going to do is I'm going to factor. Well, I see a squared minus 4 again is in the form a squared minus b squared, and that will factor to be a plus b, a minus b, where I notice that my a is a and my b is 2. So a is a and b is 2. So a squared minus 4 factors to be a plus b times a minus b. And I'm running into the same situation on the bottom, a squared minus 1. So now my a is still going to be a, but now my b is going to be 1, because 1 is a perfect square and so is a squared. And I get a plus 1 times a minus 1 times a plus 1. It's a binomial. There's no GCF and it's not perfect square minus perfect square, so it is not factorable. Remember, not everything is factorable. A squared plus 2a has a common factor of a. It has a GCF, so I'm going to take my GCF out and I'm left with a plus 2. Now that I've factored everything, I'm going to go ahead and cancel. Well, a plus 1 and a plus 1 cancel. A plus 2 and a plus 2 cancel. And it doesn't look like anything else cancels. Remember, I cannot cancel anything that is not a full factor. It has to have the entire factor in common, not just part of that binomial. So now multiplying straight across, I have a minus 2 on top, and that is it. And on the bottom, I have a minus 1 times a. I have to go ahead and look before I reduce to determine what my domain restrictions are. So a plus 1, when does that equal 0? A minus 1, when does that equal 0? A, when does that equal 0? And a plus 2, when does that equal 0? Well, a minus 1 equals 0 if a is negative 1. Excuse me, a plus 1 equals 0 if a is negative 1. A minus 1 equals 0 if a is positive 1. A equals 0 is already solved for me. And a plus 2 equals 0 if a is negative 2. So my domain is a cannot equal negative 1, a cannot equal 1, a cannot equal 0, and a cannot equal negative 2. So here is my final answer, as well as my domain with any restrictions listed. So to quick summarize the steps for multiplying rational expressions, I'm going to first factor. After I factor, I'm going to go ahead and cancel any common factors. After I do that, I'm going to make sure and rewrite my answer in simplest form by multiplying straight across top and straight across bottom. And look back at my denominator from before I canceled and use that to help me write my domain restrictions.